Right, this is video 3 for chapter 23, still talking about electrical currents. This is pages 442 to 447. Right, there are two types of currents that can be flowing through a circuit. The first type we're going to talk about is direct current. It's abbreviated DC, so when I talk about it from now on, I'll probably just call it the DC current or DC circuit. In a DC circuit, charges only ever flow one direction. It's always from negative to positive. These would be like a battery circuit. So anything that is run off of a battery is going to be using a DC circuit. The battery, the charge flows from the negative end of the battery around to the positive end of the battery, which is the voltage. And so the current is flowing through the circuit. The battery is pumping it through, being the voltage pump there, and it is always going to flow from negative to positive. So it's only going one direction. It's direct current. Alternating current is the other one. It is called AC. And when in an alternating current, the charges first move one way and then they turn and they move the other way. And we'll talk about this more in the next couple chapters, because the reason alternating current exists is because the way the electrical grid was developed around magnets. And so it has to work this way because of the magnetic and the electrical fields that are created. But what this really does is it alternates the polarity of voltage at the source. So where the voltage is coming from, it's going to flip directions one way and then the other. So in the power lines and stuff, when it's passing through, it's alternating current. What's coming into your household is going to be alternating current that then has to be changed in order to be used in normal circuits in our homes. So the reason that they use alternating current is because it's the easiest way to transport it. We'll talk about that one in the next couple of chapters when we talk about the transformers. So in the United States, our alternating current is either a 110 or a 120. But in Europe, it's a 220. So if you've ever gone overseas, you usually have to have to take your phone and to plug it in and charge it, you're going to have an adapter, because our stuff doesn't work in Europe and their stuff doesn't work over here because our power supply is different. So when you plug in your phone or you plug in something and you're recharging, especially a battery, and you're plugging it into the wall. So we'll just talk about your laptop or your phone, which runs off of a battery. So you have devices inside that takes that AC current and it converts it into DC current so that your device can use it. The first one's called a diode. What the diode does is it limits the flow to one direction. Okay, so it only accepts the direction that it needs and it ignores the other side. So remember, AC is changing directions. First it goes one way and then it flips and turns. So the diode takes it and only accepts that one direction, which is going to make it kind of bumpy and rough. There's interruptions, there's gaps. So the second device is called a capacitor, and what it does is it takes and it evens out the bumps so that our devices will work without like turning on and turning off and turning on and turning off. So those are the two devices that are going to be inside your electrical devices that in order for you to use AC current. So some of your calculators may plug straight into the wall. Your calculators have a diode and a capacitor in order for you to be able to use that AC current, because your device is made to use a DC current. So recall that I said that electrons in a circuit aren't actually moving. We're going to spend a little more time with that. Electricity, when you plug in something and you turn it on, it is transmitted at nearly the speed of light. Okay, so when we plug it in, we expect it to turn on right away. When you flip that switch on that light, you expect the lights to come on right away. That's because they are transmitted very, very quickly. Electricity is transmitted nearly at the speed of light. If it were a little slower than the speed of light, we probably wouldn't tell because it's really, really fast. But keep in mind that, remember, it's not the electrons that are moving. The electrons are not moving at the speed of light. In fact, the electrons are barely moving as far as from point to point at all. They're moving about their little location, migrating and rotating and vibrating and oscillating, but they are not moving from here to there. So it's the electrical field that is traveling at that speed. Once that electrical field gets turned on, then those charges, they all have electrical fields surrounding them. That pushes the electrical field moving down the line and causing the next one to move. So in a DC circuit, the field only moves to one direction. Just remember, DC means it moves one direction. The electrons do a lot of bumping around in this, and they create a lot of heat. So they will move very slowly along. There's slight migration along there. That's called drift velocity. In an AC circuit, they do not move at all. They only vibrate. And keep in mind that the electrons, because they're not moving, they have to already be there, right? So they are supplied by the conductor. So the wiring that you bought when you bought the lamp came with its own electrons. So that's where the electrons are coming from. They are already in the conductor. So that when you plug it in, you're not getting electrons from the power company. What you're getting is a field change from the electric company that goes through the wire in order to turn on the lamp. So keep in mind that electrons aren't flowing, energy is flowing. The energy is flowing from one place to the other. It's creating electrical fields within the electrons, and that is what is moving along. So how fast electric energy is converted from one form to another is electric power. Okay, so you have mechanical energy. You can take mechanical energy and change that into electric power. You can take heat and change it into electric power. You can take light into electric power. And that formula is your power is equal to your current times your voltage. So there will be problems where we are going to figure out power based on current, voltage, and resistance, because remember, current and voltage and resistance have a relationship. Power has a relationship with them as well. So your power is your IV. Remember, I is current, V is voltage. And if we were looking at that only in units, power is in watts, current is still in amps, and voltage is still in volts. There is a quiz today. Go ahead and click on the link and complete the quiz. We'll see you in class.